Okay, I'm back, and so now we want to talk about the third class of sedimentary rocks, and these are going to be the biochemical sedimentary rocks. So if we go back to our master sheet here, you'll see that now we're now talking about the ones that are in green. And so what are some different kinds of biochemical rocks? So the first one is going to be chalk, and chalk is going to be composed of calcium carbonate. So what chalk is it's composed of microscopic little animals that use the calcium carbonate to make their shells. And then when they died, they then accumulated on the ocean floor and were cemented together to make chalk. So what did they look like? Okay, so the name of the organism is going to be called foraminifera, and they are about 10 to the negative fourth meters across, and so that means about the same thickness as a human hair. That's how small these things are. So that's a magnified view of what their shells look like, and they would have used calcium carbonate to make their shells with. All right, then you can also have fossil limestone. So we said that you could have limestone just from precipitating from ocean water. But you could also have it, organisms could use the calcium carbonate to make their shells with, and then when they die, they accumulate on the ocean floor and then are cemented together to make fossil limestone. Now, if it's just purely shells that are glued together, then we call it coquina. And it kind of looks like a granola bar. So if you've ever seen coquina, you know what I'm talking about. But fossil limestone can have other things in it. So around here in the state of Missouri, we have what's known as crinoids. And crinoids were animals that lived millions of years ago, and so they had a stalk that was composed of calcium carbonate, and then they would have a head, and then they would have tentacles that would come out of the head like that. But then what would happen is when they would die, they tended to die on near a beach, and so wave action would rip apart all of these pieces, and then when they would be cemented together, it'd be just a jumble of these little disc-like things. So that's the major type of fossil that you find in southwestern Missouri, is these crinoid things. And so if you were to glue all this stuff together, you make fossil limestone from it. Okay, what about chert? So chert is very similar to chalk, but the difference is that it's composed of silica, whereas the chalk was composed of calcium carbonate. And if we look at this picture, so they're going to be made of diatoms. So diatoms are 10 times smaller than what the foraminiferas were. And they are going to be composed of quartz, and then as they would die, their quartz shells would accumulate on the ocean floor, and then they would be cemented together. So that's going to be one kind of chert. Now there's another kind of chert that can be created the same way that you make limestone. So limestone can be precipitated directly out of the ocean water. Chert can be the same thing. So if the ocean water has too much calcium, has too much silica in it, then it can precipitate down, and you can make layers of chert as a result of that. One of the explanations for this is that they think it might have something to do where fresh water empties into the ocean, and you've got a mixing of the water, and then what happens is the water can no longer hold on to that silica, so then it precipitates down and makes the chert. Okay, what about that last one there, the peat. Okay, so this is going to form in a swamp. So where you've got trees that are growing in a swamp, when they die, they're going to fall into the swamp. Now, normally, when something organic falls onto the ground, it begins to go away because it starts to react with the oxygen in the air. It starts to become oxidized, and it starts to decompose and break down. But what would happen if the organic material, before it could start to decompose, more material fell on top of it? And then more material fell on top of it, so that the material was buried before oxygen would have a chance to decompose it. So then you're going to end up with pieces of leaves and twigs that are pressed together, and we're going to call that peat. And then if you continue to squish it and to heat it up, it's going to turn into coal. So up there at the top, you've got your original grass and leaves and things. And then if it's covered up before it has a chance to be oxidized, it's going to be peat. Then as you continue to squish it and heat it, at first it's going to turn into lignite coal. Then it turns into bituminous coal. And then finally it will turn into anthracite coal. Now, anthracite coal is not sedimentary, though. So the lignite coal and the bituminous coal and the peat are all examples of sedimentary rocks. But the anthracite coal has been heated up so much it has metamorphosized. So anthracite coal will be an example of a metamorphic rock, which we'll see in a future lesson. Okay, so those were the different kinds of biochemical rocks. Okay, let's take a break, and when we come back, we'll talk about what do sedimentary rocks tell us about their history.